All righty, friends, welcome back, welcome back. So we're going to be taking a look at multiplying and dividing rational expressions today, and then some complex fractions. So we're just going to continue going through some of the arithmetic of rational expressions. And then the next 2 days, we'll talk about graphing the functions that go with them. So when multiplying, the first thing we always want to do is factor each denominator. So factor each denominator. So, or not denominator, actually, I'm sorry. Factor each fraction. That means we're going to be using all of our factoring rules again, greatest common factors, special factoring rules for difference of squares, sums of squares, difference of cubes, not sums of squares, sums of cubes, difference of cubes. And then also if there's a trinomial, then also looking at the box and diamond or factor by grouping or any of that other type of stuff that we've done before. So if you need to go back and relook at the factoring review video, go for it. Otherwise, friends, basically all we're doing is we're going to end up doing a lot of factoring. So x minus 4, and I know you guys at this point are very good factorers, so I'm not going to worry too much about the factoring. And then we factor the denominator. We have 2x plus 1. X plus 3. So we go through and we factor all the numerators and denominators. Factor each expression. It's like 4x squared minus 1. That's a difference of squares. So then we have 2x minus 1, 2x plus 1. And then the 5x minus 20, we're going to factor out the greatest common factor of 5, so x minus 4. So we factor out all our terms. The next thing is, if this is a division problem, we would take the second fraction and we would do the reciprocal. We'd flip it. Then again, this is multiplication, so we don't worry about that. We can just move on. Don't have to worry about any flipping stuff. The second part, or the third part then, is cancel out any factor you see on the top and the bottom. Because, again, when you're multiplying, you just multiply straight across. So it's as if we were dealing with everything anyway. So again, multiplying is just going straight across. So essentially we can just pretend, if we wanted to, that this was just one big giant fraction. And we can cancel out all the stuff on top and bottom. So we're going to cancel out any factor we see on top and factor we see on the bottom. So here we go, x minus 4. I see that down here. X plus 3, I have that right here. 2x minus 1, I don't have that, but 2x plus 1 I have. And then whatever's left over, I'm going to write that as a single fraction. So I multiplied all the way out, and that's essentially what we mean by multiplied out. That doesn't mean if there's multiple factors, multiply those together. You don't have to do that. Just put it all together. All right, friends, why don't you pause the video and see if you guys can't take a shot at this next one. All right, let's see how y'all did. I have x minus 2, x minus 1, all over, is that 2x minus 3 and 3x minus 2. So we go through and we're factoring every term. So it's a big, giant factor problem. So for those of you guys that like factoring, this is right up your alley. You're going, Williams, I'm not a big fan. Well, maybe not right up your alley then, right? So that's all right. 3x minus 2, x plus 1. And then on the bottom here, I have x minus 2, x plus 1. So again, we're looking for common factors now on the top and bottom. So x minus 2, do I have that? Yeah, top and bottom. X minus 1, I just see it on the top. 3x minus 2, got that one. X plus 1, I have that one. So whatever's left over, that'd be my answer. So I'm going to be left with x minus 1 all over 2x minus 3. All righty, friends. So far, so good, hopefully. We're just going to keep right on going here. We've got a couple more to try. Why don't you guys pause the video and give these two a shot. Again, remember with division, though, flip your fraction. Okay? So pause the video and try both of these. Let's see how you do. All righty, here we go, friends. So first thing I do is I do see division. So because it's division, I'm going to go ahead and flip my fraction to begin with to turn into multiplication. So division becomes multiplication. That is an ugly multiplication symbol. I blame myself. That's a little bit better. And that means then I'm going to flip that second fraction. We multiply by the reciprocal when we divide. So from there, now we got, look at this, I got a sum of cubes, I got two difference of squares. That's all right, we're just going to go ahead and bring everything out we can. So x minus 1, x plus 1. And then we have a 4 times x plus 2. And then we're multiplying by x minus 2, x plus 2. All over, and now I have a sum of cubes. So I'm going to use my SOAP formula here. So there's my two perfect cubes. X squared. X times 1 would be x. 1 squared would be 1. Then I have the same sign. So since it was plus, this is plus. Opposite sign, that's minus, and then always positive. And we're going to cancel out those common factors here. So here we go. X minus 1, do I see it? I don't. I do see an x plus 1. X minus 2, I don't see that, but I do see an x plus 2. So whatever's left over, that's what I'm going to write it out as multiplying it together. So x minus 1, x minus 2, all over 4 times x squared minus x plus 1. So we multiplied it all the way out. All right, let's see how you guys did on this one, right? If you need to pause it, the video real quick to try it, this one to fix it, go ahead and do that. All right, I want to see how y'all did here. Here we go. Again, I'm going to take that second fraction and I am going to flip it. So let me rewrite my first fraction. And if you guys choose to factor them before you flip them, totally okay with that. No problem with that. I've always just flipped it first. Try to get everything in terms of multiplication as quickly as humanly possible. That's just something I do. Again, whatever you do, that's fine. The order doesn't really matter. Either factor and flip or flip and factor, doesn't matter. All right, so x minus 4, x minus 1. Right here we have an x minus 2, x minus 3. Times x minus 3x plus 2. And over here we have an x plus 2x minus 1. And my favorite thing, we're going to start bamming out all these common factors here. So x minus 4, no, but I do have an x minus 1. I have an x minus 3. And I have an x plus 2. So that leaves me then with x minus 4, x minus 2. All right. We are carousing, friends. Let's keep going here. We got one other thing to talk about today, and that's simplifying complex fractions. So that's going to kind of essentially take all the simplifying, adding, subtracting, multiplying, dividing, and putting it all together. So to begin with, I need to always start off with getting a greatest common factor. So I see a 2, I see an x. And by the way, if there is a term that's missing a common factor, remember it does have one. It's just over 1. So I'm going to multiply every single fraction by that greatest common factor. So 3 over x plus 4 over 1 all over 3 over 2. So one of the first goals you're looking at with this complex fraction, we call it a complex fraction because there's fractions inside fractions. One of the first goals you're looking at is how do we go about getting it down to a single fraction? So we don't want there to be multiple fractions. So if I multiply every term by 2x, that's like multiplying by 2x over 2x, which is 1. So it doesn't change the value of it. And now we're going to go ahead and get rid of anything and get it down to a single fraction. So a single fraction. When we do that now, we end up with 2 times 3 plus, I'll put that in parentheses, 4 times 2x all over x times 3 plus 2 times 2. And friends, I end up with 8x plus 6 all over 3x plus 4. So I multiply by my common denominator, my greatest common factor, and then I combine my like terms in my numerator and my denominator. And now I'm going to look to see, can I factor anything out of my numerator and denominator? In this case, I can factor 2 out of here. And the reason why we're factoring is we're looking for, now that we've created this, is there any other common factors that we could possibly remove from the problem? And by doing that, we end up with something looking kind of like that. So here's what I want you guys to do. If you guys don't mind, I'd like for you to go ahead and pause the video and see if you guys can try this yourselves. Let me rewrite this on here. So go ahead and pause the video and see if you guys can try this next one down below. All righty, let's see how you guys did here. Okay. All right, so a common denominator, here we go. We've got to get all our common denominators. What do we have? See, I see an x, I see an x plus 1, and I see a 5. So I have 3 things that are going to make up my common denominator. And note, remember that this 2 here really is the same thing as 2 over 1. So I'm going to multiply for all this by that common denominator. All right, so we're multiplying by 5x times x plus 1. So every fraction is going to be multiplied by 5x times x plus 1. Put that common denominator together to try to make this get rid of all my fractions inside my fraction. I only want to just have the one big fraction. I don't want to have all these other fractions inside of it. And again, this is something that's going to come up a lot when we're dealing with proofs, trig proofs, second quarter, second term. All right, so common terms, got to make them go away. So x goes away. Let's see, x plus 1 goes away. And the 5 goes away. So when we multiply the whole thing out here, I end up with 5 times 4 times, which is 20, x plus 1. Over here, 2 times 5x, that'd be a minus 10x, x plus 1. All over, let's see here, over here I have a 15x, it looks like. And on this one, I have a positive 2x times x plus 1. So we're going to multiply it all the way out here. 20x plus 20 minus 10x squared minus 10x 15x plus 2x squared plus 2x. All righty, so we're going to combine our like terms. So I have a negative 10x squared. Looks like I have a positive 10x and a positive 20. And 2x squared plus 7x. So both top and bottom are going to have a greatest common factor that I can factor out. So I need to go ahead and factor these as far as I can to see eventually if there's anything that I can get rid of. So x squared minus x minus 2 all over x times 2x plus 17. And if you haven't done it yet, notice the x squared minus x minus 2, that will factor. So go ahead and pause the video if you need to factor that real quick. All right, let's see. When we factor that, we get x minus 2 and x plus 1. It's factored all the way down. There we go. There are no common factors that I can get rid of. That's not a problem. We just have to always double check to make sure. All right, friends, why don't you guys go ahead and pause the video on this next one and see what you guys can come up with. All right, here we go. Last problem. Notice on this one, I actually have to factor first, right? So I have to factor the x minus 1, x plus 1. And we'll use that then to help us get our common denominator. And also don't forget this 4 is over 4 over 1. So notice our common denominator, what do we have? Well, we'd have the x minus 1 and the x plus 1. If we use x minus 1 and x plus 1, that's going to go ahead and allow us to have every single factor. So we're going to multiply everything by x minus 1 and x plus 1. So here we go, x minus 1, x plus 1. Everybody gets to get multiplied. X minus 1, x plus 1. X minus 1, x plus 1, and x minus 1, x plus 1. So every single little problem is going to get multiplied by the x minus 1, x plus 1. Get rid of our common factors here, so that means these are going to go away. I always kind of enjoy just crossing off a lot of stuff. So I end up with an x plus 3 times x minus 1 all over 4 times x minus 1, x plus 1 minus x times x plus 1. All right, what do we got here? So x, I got that x minus 1, x plus 1. So let's go and take care of that real quick. So that'd be 4 times x squared minus 1. And then we got the, still have that minus x times x plus 1. Keep distributing everything in. So x plus 3x minus 3 all over 4x squared minus 4 minus x squared minus x. And if we combine our like terms, it looks like I have a 4x minus 3 on top here. And down here I have a 3x squared minus x minus 4. Well, it turns out that that denominator is actually going to factor. So why don't you go ahead and pause it if you haven't done so and factor that out. All right, here we go. I got the 4x minus 3. I'm just going to factor one more time to see, is there any common factors that I can get rid of? If there is, I got to make sure I do that. So 3x minus 4, ooh, almost. Those numbers were the opposite way, I would have been able to. And then x plus 1. So nothing factors out, so we are good to go here. All right, friends, so that kind of takes care of rational expressions a little bit. We'll talk about them a little bit more again tomorrow morning, so good luck, and I'll see you then.